time to do the virtual COVID-19 edutainment specific heat capacity lab. We've given you insights into specific heat capacity that we discovered measuring soil and water and stones in Riverside Park. And now we're ready to do a more controlled experiment using soil, also collected in Riverside Park and dried, which you saw if you've watched the rest of this video, and water. If you've watched the beginning, you know that these are two substances that have very different specific heat capacities. So we have a question for this experiment. You'll have this question in front of you while you watch this, because I will post it as a document, and it reads as follows. Which substance, water or soil, will heat up and cool down fastest? That is, heat up and cool down fastest. Go up in temperature, come down. Which substance, sand or water, will gain and lose the most heat? So we're going to gain and lose heat. Likewise, we're going to change temperature. So which one is going to change temperature faster, heating up, cooling down, and which one is going to gain and lose the most heat? I'm going to ask you to do a little research, and we're going to do that by you defining specific heat capacity, and you'll see on the sheet exactly where you have to do that. And you're going to explain why it's not the same for land and water, and explain the difference between the rate of change of temperature and the heat gained or lost by a substance. Why are those two things not the same? So I'm back again, and I have materials that we're going to need. Ceramic bowls, one for soil, one for water. And I've got my dried soil, measuring cup, and kitchen scale, lamp with a 200-watt bulb. And it's an incandescent bulb, which is important because incandescent light bulbs produce a fair amount of heat. This is the old style of light bulb. So we want to use that because the fluorescent or LED don't produce enough heat. A couple of thermometers, and I'm going to be using my laptop over here as a timer. So hello again. You may have noticed I brought actually a spoon and a second measuring cup, and I want to go over with you a section of this particular experiment that will involve some calculating on your part. And the calculation will be to determine the amount of heat that is absorbed either by the water or by our soil. How much actual heat. And if you remember in 7th grade, heat can be assessed with the unit, the joule, or an older version, the calorie. And when we heat things up, add energy to them, in this case visible light, they change temperature based on their specific heat. And we want to know how much heat it takes to change the temperature of water 1 degree versus the temperature of soil 1 degree. And to do that, we need to first actually conduct the experiment and then apply a formula. The formula is in this sheet on page 3. And you could turn there and we'll just take a quick look together. The formula we're going to use says that heat equals the specific heat capacity of the materials that we're using, and we know that for water, and we're going to tell you that for soil, times the mass of the material we're using. That's why we need our scale, because we have to measure the mass of the soil so that it measures the mass of the particular volume of water that we're going to use. So in the end, we're going to have two different volumes of the materials, but the masses of them will be the same so that they are comparable when we apply our specific heat formula. So again, the formula, I didn't finish it, It was heat equals specific heat capacity in joules per gram, the mass in grams, and the change in temperature. So specific heat capacity times mass times the change in temperature. And of course we'll be able to tell the temperature because we're going to turn this lamp on for 7 minutes and record the temperatures with these thermometers. And we will record the data on page 2. So if you look at page 2 of this sheet, you've got data tables that you'll be filling in with me as I perform the lab. You will collect the same data that I'm collecting. So we want to get the mass of the bowls. So let's get rid of these thermometers. Move this down here. And I've tared this to be at 0, and essentially that's going to make my life easier. So if I put this bowl on here and I walk around, I can see that the bowl is registering on the scale at 0. I'm just adjusting it. So now I know I can put in 200 milliliters of water into that, and it should read 200 milliliters on the scale. So let's just do that. Remember, and there we are. That's actually 200 grams of water, which, if you remember something about water, the mass and the volume are the same. Hello. I'm now going to do the same thing with my soil bowl. Grab it, place it on the scale here, and it tares to 0, which is quite nice. It's a little bit off. I'm going to lower this scale a little bit so it's tared to 0. Tearing means that I've set the scale to 0. Now I just want to add 200 grams of soil. Then I'll have the same mass of soil and water. So, I've got my spoon, got my soil, and we'll just put some in and watch the scale go up. I'm at just about 200 now. So, just put in a little bit more. So, the instructions ask you to get the density of the soil in the water. We can't get the density of the soil yet, though we should know the density of the water. And you should have been able to fill that in by now. But the soil we'll get at the end. I will transfer the soil that's in here to a volumetric container, a measuring cup, and we'll see what the volume is. And then you can determine the density. But we know we have 200 grams, okay? We have 200 grams of soil, mass of soil, and 200 grams of water. Now we're ready to put the thermometers in the dish and start recording every 30 seconds for 7 minutes the heating, soil and water, and then turning the light out without touching anything, and the cooling. So we're going to go up and we're going to go down over a 14-minute period. So I've placed thermometers in both bowls and giving them a chance to equilibrate. The water's been out in the air for a while, and the water temperature reads at 21 and the soil temperature reads at 21. So that's a good place to start. But we have to adjust our lamp. Our lamp is going to be on for both. Now in the lab, if we did this together, we would be doing it so that I do it one at a time, but I'm going to do it together. It's a little bit of a compromise. But what we need is the lamp to be a certain distance from the edge of the bowl, and I'm just going to use this centimeter measure, and I've got it now at 16. What we need to do is start timing. So I still have starting temperatures at 21, so I'm going to put those down. And I have my mass both at 200 grams. I'm putting them down. You can do that too. And now I'm going to reach over. I'm going to turn this on and start my timer simultaneously. So you'll eventually see, we now keep this on for 7 whole minutes. And I'm resetting and starting again. And my temperature is still 21 and 21. Reset, start, and my temperature is still at 21 and 22 for the soil. 21 for the water and 22 for the soil. And I'm still at 22 on my soil and 21 on my water. And I'm at 23 on my soil and 21 on my water. So you can see already that the soil is changing temperature at a more rapid rate than the water. The water is barely doing anything, or it's not done anything. So I'm on my last 30 seconds, last 10 seconds of heating. Then we're just gonna turn off the light and keep going. And we've made it up to 28 on the soil and 22 on the water. So reset, start again, and turn this out. And my final temperature for the water is going to be 23. And my final temperature for the soil is going to be 29. So how much heat we gained, we can now figure out. And after 7 minutes, we'll know how much heat we lost. 2, 1, reset, start. My soil it's dropped to 28. And the water is still at 23. And we have cooled from 29 at our highest down to 25 on the soil, and the water has lost really nothing yet. And my final one for this is, we're again at 25. I'll call it 22. So we're done. So we did 14 minutes, you missed a little of it. And on the heating side, the soil went from 21 to 29, gaining 8 degrees. The water went from 21 to 23, gaining 2 degrees. And then just turned off the light and cooled from 29 to 25, so a change of 4 degrees, and the water cooled by 1. And for now, that's the data that we need for completing the tasks that make up this specific heat capacity lab.